we'll start playing Haskell program language. This is day one for Haskell here. And in our last video, we installed Haskell GHCi environment on our Mac computer. So if you are using a Windows computer, I also have a tutorial on Median. So you can search Median Haskell on Windows, something like that. Then, yeah, there's detailed steps about how to install Haskell on Windows. Okay, and today we won't talk about that. We'll start playing, right? GHCi. Okay, so let's close that, and we'll follow this book. This is a great book. Okay, you see here I have another tutorial here, still in Median. Okay, so programming in Haskell. Yeah, you see here I said learn Haskell from Graham Hutton. Yeah, this book. This is the great book. It was used, and I think it has been used in some universities. Very professional, and yeah, this guy is a great professor, okay, in this area. So let's start on our terminal of MacBook. So this is the terminal. Okay, so before we start, if you are new to the terminal or Unix environment, let me show you some terminal basic command. For example, date. You can see the date, and do we have time? Yes. And pwd is show where you are, right? And ls list all the files under this directory, and ls-l is means long format. It's like that. Okay, so all those are everything under this my home directory. It should be same as what we see on Finder. Same thing here, my home. Yeah, you see the list here is the same as what is displayed here. Okay, so what else? And there are some command. Yeah, you can simply Google like a terminal command, blah blah blah, right? Like a copy file, make directory, and change directory, right? Something like that. So today we'll just use the GHCi we installed in last video. GHCi, right? This is our Haskell environment. So let's go into GHCi. Yeah, see, GHCi version 8.10.1. This is the latest one, and this is the default prompt prelude. Let's change it. Yeah, let's change it to the famous lambda. Okay, so set set prompt. Now how to get the lambda on the MacBook computer? Control command space, right? We'll get that. Okay, I already have the lambda there. If you want to search, you can do lambda, right? Lambda. Then okay, I like this one. Okay, double click. Yeah, space. Space. No, let's add a colon there. Now you see, cool, right? So what can we do with Haskell? Haskell is a different programming language. It's called functional programming language. Yeah, don't try to understand its advanced concept, and just focus some simple tasks we are try. Okay, It's a different language from something like Java, Swift, even though Java and Swift also have functional features. They are different. So we can do here, right? Something like basic arithmetic calculation. So like 4, 2 plus 3 times 4. Yeah, 14. Okay. And the other one, yeah, you get it, right? So the GHCi can pass the expression, arithmetic expression, right? Yeah, 20. Yes, 5 times. Okay, it can also do square root. Square root. What? Like, yeah, this is a Pythagorean triple. So 3 to the power of, to the second power plus 4 to the second power, right? Pythagorean triple, so it will be 5. Oh, yeah, 5.0. This is a different type. Now, so how do we know this is like, can we get the information about that? Yes, we can use :I information about a command or function. Yeah, you see, type is status. Yeah, we'll learn this later. And there's a class for that, function or something. Yeah, so here is, wow, is the function name, and it maps a number to another one. Okay, and it's defined in here. And we can also check the type of this one. I think it will display something like, I don't know, let's see, T, SQRT. Oh, is floating. Yeah, the type is floating number, right? Floating number, a number mapped to the other. Okay. And what else? The system provided function we have, maybe yeah, actually this plus, right? 2 plus 3, the plus is a function also. It is an operator, but we can check. We have to use the parentheses around it. So this is like addition function. Yeah, it maps. Wow. Don't worry about the syntax here. It means we map 2 numbers, right, to another one. So it's like this 2 is this number A, and the 3 is the second one, and this 5 is the last one. That's A here, last one. Okay, so now let's introduce array. No, it's not called array. It looks like an array, and it's a sequence, right? Like that. 1, 3, 0, 5. This is a sequence. Okay. Look here. There are different system functions to handle those arrays. Head, guess what does it mean? The head of, right? The head of sequence, yeah, is the first element here. First element here. So what about tail? Tail is not the last one. Is everyone except the head. Okay, so tail. We can define this one to put it in a variable or constant. So can we say A equals Let me make a copy of that. Copy, paste. Yeah. So A is that. Let's show A. Yes. So now I can save some typing, right? So head A. Yeah. 1. Tail A. What is that? It will be this part, right? This is the tail. So starting from the second one to the last is the tail. Yeah. It's also a sequence. Let's check its type. Okay, so type head. Yeah, it maps our sequence, right, to a number or an element. Yeah. So it doesn't have to be a number. It can be a letter. Let's check this information about that. So yeah, it's called list. The official name of this one is list. A list. Yeah. This is very, very important data structure in Haskell. It's the foundation of Haskell. So we have to be very, very comfortable with that. And yeah. Now, so let's try some other type of the element. Okay, so what about, let's B equals another list. So say hello. We don't need that. Hello, right? This is a list of letters. So B. Oh, interesting. It doesn't show in this form, right? In this format. So you guess this one is exactly same as this one. There's no difference between them. Okay. And now let's check the head of B. Okay, this list, B list, head B. What do you guess? H, right? Yes. What about tail? B. ELLO, right? So if we say this one is exactly same as this one, can we put this guy as the parameter of head? Let's try. Head, hello. Yes, it works. And the tail and hello, same thing, right? Now, what's the next? Oh, here, this double exclamation mark, right? Double exclamation mark. It means which element we want to get out. Let's check this guy. Is it? Maybe we need a parenthesis for this operator. What's its type? Unknown command. What about I? Oh, maybe. Sorry, I forgot the I here. Okay, so let's try it. Yeah, so this is a function, right? It's also a function in map. So given a list, and now here follow the number, right? Like this one here. The third, right, is the index starts from 0, 0, 1, 2. So 2 is the third element in the list. It's like in Java we use, right, square brackets for the subscript, right? In Java we say like for example, a sub 2, right? But in Haskell, we do a double exclamation mark. We also say sub, right? Sub 2. 0, is it? Oh, yes. See, here, the third one is that. So let's try the first one, 0, 1, right? So A is that. So A, the first one is that. The last one should be 3, right? Yeah. 5. Now let's check the B, the first letter, H. Yes. Now we have introduced, yeah, head, tail, and take. Yeah, take. You will take how many, right, elements from the following list. So 3 means the first 3. Yeah, easy. And okay, so let's introduce a syntax like that. So we can do 1, 2, 3, 4, right? 5. We can also do this dot dot 5 inclusive from 1 to, yeah. We can also do some give the list a hint. For example, 1, the second one is 3 instead of 2. So you can play with that until 9, for example. You see? It will follow this pattern. 1, 3, 5, 7, 9. Okay, what about we put 8 here? It will stop at 7. Yeah. Yeah. So let's change this to a greater step. Okay, so say 4 and 18 put it here. So now 1, 4, 7, right? You will follow this pattern. Cool. Now take. Okay, let's do take. So take how many? 5 from 1 to 100. Okay, 1 to 100. 5. So let's see, 1 dot dot 100 is, yeah, so many, right? 100 elements in the list. And let's stop here and see you in our next video.